Today's video, I'm going to look at an example of a linked list, singular linked list code example. And as you can see over here, I've already defined some functions. I've called it DLL list, and it extends the comparable T, so you can send in any type. And I've defined a head, and I've defined a tail, both as null, and then the size of the linked list, so the length. And then I also have a linked list class definition here. We have some value which we are holding in each linked list node. Then we have our next pointer to the next one, and we also have our constructor which will put a value into the linked list, and it takes in the value you want to put in, and then also a string output of the value for that linked list, which we will use in a string function to output our linked list, so we can check that we are doing all the operations correctly. So in this video, I'll be doing an insert and a delete, so a add and a remove. Over here, I've already written remove head and remove tail. I will explain those, however, but it's unnecessary to code them in this video. So let's get started with the add function. So how do we add an element to a linked list? Well, we first have to check, is the list empty? And then we have to check if the value at the head is bigger than the new value. If the value at the head is bigger, that would mean that we'd have to insert it before head. And because we are putting the elements in numerical order in the list, so we'd have to check if the value is bigger than the head's value so that we can insert it before the head. And then of course we just do a normal insert anywhere in the list if that's not the case. So first we're going to say if, let me just put my caps lock off, if it is empty. I've already written an isEmpty function, by the way. The isEmpty function simply checks if head and tail of the list are null. So it's nothing complicated. So if it is empty, well, then we're going to want to add it into the head, right? So we open our curly brackets and we say head is assigned new DL node, because that's what we called our class, and we want to create it with the new value. And it's as simple as that. And then of course we want to increase our size, which, remember, we defined our size up here. So we increase our size, and then we just return from the function. So we first check, is it empty? Then we said we're going to check, well, if the value at the head is bigger than the new value, and then we're going to do the reverse of that. So else if. So here we can use the compare to function, head.value.compare to value is greater than 0. If that is the case, then we want to insert the element before head.value because it's less than the head's value. So because we are storing them in ascending order. So DL node temp, we're just creating a new node for the new value. So a new DL node. And of course we're going to put value in there. And because it's going before head, we want to say that its next will be head. But then of course head is now after temp, so therefore we have to say head, the new head, which is just the normal head variable, will be temp. And then we have to increase our size to make sure we maintain the number of elements within the linked list, and then we can just simply return. Okay, so that is two parts of our insert function. The next one is when we're going to insert the element somewhere else in the list. It's bigger than head, so it has to go somewhere else within the list. So now we have to traverse the list to find a place in the list where it must go. So now we have to create a traversal variable to traverse the list. So it's going to be assigned head. Some say, well, why don't we just use head? Well, then we're going to say head is assigned head.next, and we'll lose our head pointer. And we also want to keep the one before temp because we might want to redirect pointers when we insert our new element. So therefore we're going to make that null for now because we have nothing to put in it yet. And now we have to traverse the list. So we're going to say while, we're going to create a while loop, if I can get my brackets correct. So now we are going to say while temp.value.compare to value, which is the value we imported, is greater than 0, sorry, less than 0, because we want to check that temp's value, which is in there, is less than value. So while this is true, and we also have to check that our pointer doesn't go to null. Okay, so basically what we're doing there is we're traversing the list until a value bigger than the value to insert is found, and then we know we can insert before it. Okay, so now we're just going to traverse our list. We're going to say prev is assigned temp. So the previous will get temp, and temp will get the next one of itself. And of course we're checking to see that temp.next over here is not null. Therefore we know that cannot go null in the assigning. So temp will never go to null in that loop. Okay, so now we've more or less found the place where we want to insert. So therefore we can say if temp.next is null, we just do a check. We always do checks like this. So if the value of the next point is null, then we know we can just insert after it. But we have to do another check. We have to check, is temp.value.compare to, is this still true? Because this might have been true, but that might have been not true. Because both have to be true for that while to be entered. So we have to check again. If temp.value.compare to value. Why are these brackets doing this? Value is less than 0. Let's just take that bracket away. So if the value that is in the list is less than the value we want to insert, well then we know we can insert it after it safely. So temp.next is assigned the new node with that value, new DL node with this value, and then we have to increase our size, and of course then we would want to return, because then we know we've safely inserted the value. So what if temp.value is greater than? Well, we can check for that. Let's just copy this, it'll make it quicker, paste, and then just change this to if it's bigger than. Well, then we're going to insert before temp. So now this is a little more complicated. So DL, we're going to have to create a temporary node. DL node insertee. I'm just calling it insertee. Is assigned a new DL node with the value. You can also create a node to insert before entering any of this. So you can create it after you've checked if it's empty. Then it will reduce the amount of times you have to type creating a new node, but it doesn't really matter. Okay, now we say insertee.next is assigned temp. So we preserve the next pointer of prev to temp by doing this, but it doesn't really matter in this case because we have prev.next is assigned insertee. And now we can safely make prev point to insertee. So what I've done here is I've said, okay, let's create a new node. Then insertee's next will be temp. So prev used to point to temp. So now I'm making insertee point to temp, and we're making prev point to insertee. So it's prev points to insertee, and insertee points to temp. That is what we're doing there. And now we increase our size. And of course we can return. We've safely inserted it. Okay, now we have to check what if temp.next is not equal to null. So we said if temp.next is equal to null, and that's the code we wrote for that. What if it's not equal to null? You can simply write else, because it's either null, and if it's not null, then it's not null. That's the only option there is. So if temp.next is not equal to null, then we have to reassign pointers before and after. So dl node insertee is assigned new dl node with value. Then we're going to say that insertee.next is assigned temp. I'm going to make it point to temp. So now we say prev.next is assigned insertee. So basically we're inserting the new value, we're inserting it between prev and temp. We're making insertee, prev used to point to temp, so now I'm making insertee point to temp, and we're making temp point to prev. No, I lie. We're making prev point to insertee, we're making insertee point to temp. Because insertee.next is temp, and prev.next is insertee. And now we can say size plus plus and return. Okay, and of course I've written a main function over here that will test it. So public class main, and then I've just written a main function which we define like this. And then I've created a new object of type integer of a list, and then we just insert some elements. So we just say let's insert from 12 to 18 with a normal for loop, and we add it and I print it with the print function I'll show you now. And then I insert some more values before that to check that it really works. So from 0 to 4, but in reverse order. Okay, so the print function if we get there. So all the print function does is it gets the get string from the dl node class, and it basically prints them out with brackets. So that's all it does. The code will be available in the description below. Okay, so let's see if our functions work. And as you can see, it inserts perfectly. So it inserts 12 first, then 12 and 13, then 12, 13, 14, and so on. And over here we can also see 4 inserts 3, 2, 1, and 0.